Good afternoon, everyone. It is 2 o'clock. Let's get it started. My name is Yilin Zhuang. I'm a Water Resources Regional Specialized Agent with University of Florida Institute of Food and Agriculture Sciences. I'm part of 5 water RSAs located across the state, and I cover the Central Florida region. My office is located in Apopka, the Mid-Florida Research and Education Center. Have you heard of Extension? If not, Extension is a partnership between state, federal, and county government to provide science-based knowledge to the public. It is an information era. With the advancement of technology, we could virtually find anything and everything online, but the question is if the information is from a reliable source. As UF IFAS Extension, we have University of Florida as our support. We deliver university-based and research-based info. And this link, you can find our webpage. Thank you for all your interest in this webinar. This talk is part of the private well and the septic system webinar series. We have already covered the basics of private wells and hard water. If you missed these talks, you can find the recording through these links. I will also share the slides with you after this webinar. To prevent inappropriate use of the recordings, it requires you to register before viewing the recordings. And here are the upcoming webinars. Next month, we'll switch gear and move on to one potential contamination source of your drinking well water, septic systems. And before we move on to today's talk, I want to just do a quick poll so I can understand attendees better. First question, let me get a poll here. So the first question is this your first Zoom experience? Great, I see all the numbers popping up and everyone indicated this is not your first Zoom experience. I gave 2 more seconds, make it to 25 seconds. And I can share the results with you all here. You can see you are all familiar with Zooms. That's great. So I will skip the Zoom tutorials. Just one quick FYI, the chat function is disabled. So if you have any questions, just go to the Q&A function and type your questions there. And another question here, I want to get a few of, is this question. Are you living in Florida? So most of you have already voted. So let me show you the results here. So most of you live in Florida. Just a few responses show you don't live in Florida. So most information here, because today's talk is lead in drinking water. So most top content is like universal, it's generic, but I include something it's basic for Florida. It's Florida's regulations. So different states, they may have a little bit different regulations. So when we get to that point, I will probably expand a little bit more. All right, so let's get today's topic started. So before we discuss lead in drinking water, first, let's look at where lead comes from in general. The chemical symbol for lead is Pb. It comes from the Latin plumbum. I hope I say it correctly. It is the root for plumbing. Lead is an element that does not break down into less harmful substances. Lead has been used as an ingredient of gasoline, paint, glassware, metal pipes, and food containers. All of these have contained varying amounts of lead. Therefore, even though lead has been banned from gasoline and most paint and is no longer used in food containers, some lead can be found in food, paint, soil, dust, housewares, and drinking water of many American families. Lead paint and dust are the primary source of lead exposure, especially in older homes. Leaded gasoline has caused lead contamination of soil near roadways and in urban areas. However, it has been largely replaced by unleaded mixture since the 1970s. Drinking water is usually a small source of exposure to lead, but this also varies greatly among homes, schools, and other buildings, and can add to other lead sources. So here's additional information if you want to learn more about lead poisoning prevention. The first link is from Florida Department of Health, and the second link is provided by the Centers of Disease Control and Prevention. So we know lead has been used as an ingredient in a variety of products. How does lead get into water? In rare cases, lead gets into water as a result of pesticides that were used decades ago or industrial activities that contaminate soil and groundwater. In other words, lead rarely naturally occurs in groundwater. Lead is much likely to enter water from household plumbing. For this reason, lead is a potential concern for all homes, whether you are on a public water supply or private wells. The water itself dissolves lead from leaded solder or lead pipes in plumbing systems. It's called corrosion. Lead can corrode from metal faucets and fixtures made from brass, an alloy of copper and zinc that often contains lead impurities, including chrome-plated brass fixtures. Brass fixtures can leach lead even in homes with plastic water lines. Solder is an alloy of tin with lead or silver. Lead may also originate from corrosion of brass fittings on certain types of submersive pipes used in groundwater wells through the mid-1990s. Laws have restricted the amount of lead allowed in newer pipes, fixtures, and solder, but many homes contain older materials. Corrosive water also degrades copper plumbing, which may produce small leaks, blue-green stains, or metallic taste, but these are not reliable indicators of risk of lead in water. The amount of lead corroded from metal plumbing generally increases as water corrosivity increases. Water corrosivity is controlled primarily by the water acidity and the calcium carbonate content. In general, acidic water that has a pH less than 7, it's more corrosive than the water's pH is higher than 7. Water that is low in calcium carbonate is more corrosive than water that is high in calcium carbonate. So in addition to acidity and calcium carbonate, many other factors can influence the water's corrosivity. Soft water tend to be more corrosive than hard water. So we went through what hard water is in last month's webinar. Hard water has high concentration of calcium and magnesium. And for soft water, usually it's low in dissolved solids like calcium and magnesium. Florida's groundwater is generally hard. The calcium concentration ranges from 150 milligram per liter to 200 milligram per liter. And also, warm water is more corrosive than cold water. These are just some general rules. Keep in mind, any kinds of water, including hard, soft, acidic, or non-acidic, can contain dangerous amounts of lead. As I mentioned earlier, lead rarely naturally occurs in groundwater. If your city water distribution system and your home plumbing system do not contain lead pipes, lead solder, or brass fixtures, your drinking water probably does not contain significant amount of lead. So what is the significant amount of lead, or how much lead in water is too much? Guidance from the Centers for Disease Control and Prevention suggests the blood lead concentration over 5 microgram per decimeter of blood may indicate lead poisoning. Various studies have found that blood lead concentrations are positively and significantly related to the amount of lead in drinking water. Accounting for other sources of lead exposure, such as food and dust, the U.S. Environmental Protection Agency set a maximum allowable concentration of lead in public drinking water at 15 micrograms per liter. Many experts, however, on lead toxicology believe the safe level should be 10 microgram per liter or less. But for the purpose of this discussion and this presentation, we will use the EPA's level at 15 microgram per liter. Keep in mind, lead serves no beneficial purpose in human body. It is best if drinking water contains no lead. In addition, state drinking water standards must be at least as strict as EPA's drinking water standard of 15 microgram per liter. Another note here is I use the unit microgram per liter. Some other, if you do water testing, you may see ppb. They are the same. So microgram per liter equals to ppb. So far, we know that lead is much likely to enter water from household plumbing. It is a potential concern for all homes, whether on public water supply or private wells. So how do I know how much lead in my drinking water? So let's first look at public water systems. So for public water systems are required to perform routine water quality testing to ensure that water quality or the water they are providing their customers meet state and federal standards. In Florida, lead is monitored under 2 separate regulations. The first one is the Inorganics Monitoring Rule. It requires community water systems and non-community water systems to monitor for lead at each point of entry to its distribution system. In other words, after the water leaves the water treatment plant, but before it reaches the water system's first customer. And here, it's the regulation for public water system. I use the term community water system and the non-community water system. The difference here is just how many residents they serve. Both fall into the category of a public water system. So by Florida definition, a community water system means a public water system which serves at least 15 service connections used by year-round residents or regularly serves at least 25 year-round residents. So non-community water systems, they're still public water systems, but just serves less than 15 service connections. And the other rule in Florida is the lead and copper rule. It requires community water systems and non-community water systems to collect first draw samples from water taps in homes and buildings that may be or are at an elevated risk of lead or copper concentration. It takes into account the presence of lead or copper pipes and fixtures and the use of lead in pipe solder used to connect lead or copper pipes. Selecting these high-risk sites is a more effective method of targeting sample locations that may pose a greater risk to public health, as opposed to the approach of selecting monitoring sites based solely on geographic distribution across a water system service area. The lead copper rules require first draw water sampling, which I will explain in next few slides what first draw is or what does it mean. So this rule, the lead and copper rules require the sampling from homes and buildings. Then the question is how many samples are required? The number of water samples that a public water system must collect and analyze for lead and copper depends on the size of the population served by the system. So in the middle column, you can see it's the standard number, and generally the public water systems must monitor the water quality every 6 months. For some systems, based on the results submitted to the Florida Department of Health, they may reduce the number of sample sites and frequency, which you can find on the right column. So what public water systems can be eligible for a reduced water monitoring frequency? For a public water system to qualify for reduced water monitoring, such as once a year or once every 3 years, instead of every 6 months, it cannot experience any of the following circumstances, which include lead and copper exceed action levels, change of the water source, change of the water treatment methods, failure to operate at or above the minimum value or within the range of values for water quality parameters. If your water is sampled, the public water system must notify each participant the water results within 30 days, regardless whether the results exceed action level for lead or copper or not. For those who have not participated in the tap water sampling, you can still obtain your water quality report. Local water utilities are required to provide their annual water quality reports to their customers. Sometimes you can find that report online, and sometimes you may need to contact your local utility to obtain a physical report or a digital report. So previous slides, we focus on public water system. How about well owners? Different from public water system, private wells are not regulated. The management and protection of well water depends on well owners. What well owners can do to make sure the water is safe to drink? Annual water testing need to be a routine. The basic water testing includes bacteria, nitrate, lead, and any contaminants of local concern. You may need to test your water more than once a year if you experience a change in taste, odor, or appearance of the well water, or if a problem occurs, such as a broken well cap, or flooding, or a new contamination source. The well has a history of bacterial contamination. The septic system has recently malfunctioned. Family members or house guests have recurrent incidents of illness, or you have an infant or elderly living in the house. Public water superintendent is responsible for drinking water quality, meeting the EPA standards for drinking water. These two links provide you the details of the federal maximum contaminant levels for public water systems. Although private well water is not required by the drinking water regulation, it is a good reference when you have your water tested. The maximum contaminant levels are set by the Safe Drinking Water Act. It was originally passed by Congress in 1974. The law was amended in 1986 and 1996, and it requires many actions to protect drinking water and its sources. The 1996 Safe Drinking Water Act amendments extended lead regulation, further including private water supplies by requiring lead-free pipes, fittings, and fixtures in new construction and replacement parts. The 2011 Federal Reduction of Lead in Drinking Water Act redefined lead-free. So lead-free is not 0% of lead. So according to the 2011 Act, lead-free was redefined to up to 0.25% lead on surfaces in contact with drinking water for consumption. And for solder, it needs to be less than 0.2% lead. This Act, Reduction of Lead in Drinking Water Act, redefined lead-free based on the 1986 Federal Safe Drinking Water Act, which back then lead-free was defined as less than 8% lead in pipes or fixtures. So now from 1986, we strict it from 8% to less than 0.25% lead in pipes. Although regulations are in place to control lead in drinking water, only water testing of each home can determine the actual presence of lead. If you are concerned about lead in your drinking water, you should arrange for a water test from a certified lab, no matter you get your water from a public water supply or from a private well. In addition, because of the large variability in lead levels among homes, you should have your water tested for lead, no matter what levels of lead are in your neighborhood houses. So as I mentioned earlier, public water systems during their water quality monitoring, they collect first draw samples. First draw means the water has sat in the plumbing system overnight, or at least 6 hours without any activities. No turning the water for brushing teeth or even flushing your toilet. So just let the water sit there for 6 hours at minimum. This sample determines if lead accumulates in your water as it sits in contact with the plumbing system. Some of you may wonder where I can get my water tested. Do I have to use a certified lab? Can I use these testing kits? So you can see from the description here, some water testing kits, they list a lot of indicators they can test, including lead. So I did a comparison. I tested the basic water quality indicators using these testing kits and the lab equipment. So the bottom line here is these testing kits are not sensitive or accurate enough for critical water quality parameters, such as bacteria, nitrate, and so. When the testing kits tell you your water has a problem, you probably already knew it or already experienced some symptoms. These testing kits, however, for non-critical parameters such as hardness, pH, these kits are fairly accurate. So we still suggest you using a certified lab for your annual water testing for bacteria, nitrate, and lead. At the end of presentation, I have a link to the certified labs. These certified labs can be a lab operated by your local health department, or they can just be just a commercial lab. If you test your water and your first draw water testing shows the results, the lead concentration is more than 15 microgram per liter, you should stop using it immediately and find an alternate source of water until the problem is resolved. And to better understand the source of lead, whether it's from the household or it's beyond the household, it is suggested taking a running water sample. So a running water sample different from first draw, because first draw you need to let the water sit for at least 6 hours. And a running water sample is the opposite. You let the water run for at least 1 minute. So it's more like you flush the system and let's see what's the concentration of the lead in the running sample. So if your first draw water test results is above 15 microgram per liter and your running water lead concentration still remains above 15 microgram per liter, then lead probably present in the water before it enters the household plumbing. So it came from, like if you are on a well, it might be from your pump, especially those submersive pump parts. And it could also just from the public water systems. So in that case, if you get your water from a utility, contact your local water utility or your water supplier. And if you receive water from a well, then contact your local health department. So keep in mind, the health department will not take actions or handle this issue if it's not from the wellhead. Because if it's household plumbing, local health department may not do a lot. They may give you suggestions how to locate the lead source. But since it's inside the household, health department may not do a lot. So that's we suggest you do 2 tests. You test the first draw and then you do the running test. Both are above 15 ppb. Then highly likely lead is from beyond your household plumbing. So if your first draw water test is more than 15 microgram per liter and the running water lead concentration is below 15 microgram per liter, lead is probably leaching from your household plumbing. When it's not, so the first thing is to try to find and eliminate the source. Sometimes it can be nearly impossible or be or not cost effective. So when it is not possible to eliminate the source of lead contamination, the best option is to use an alternate source of drinking water, such as a bottled water, or install a treatment system on the faucet in the home, and you draw water from drinking and cooking from that faucet only. So when you search for the contamination, like I mentioned, it's highly likely from the plumbing. So if you recently have done a renovation, like your kitchen renovation, so probably check if it's from the fixtures, from the joints, if any like solder contains contains lead, or just the fixture itself. So another, when you check the source, it's the pipes. I understand now in Florida, most pipes are PVC pipes. The pipes itself is plastic. Doesn't mean other parts, like I mentioned, the joints and fixtures. If it's a brass fixtures, it may still contain certain amount of lead. And another source could be it's your electrical equipment, including telephones, has been grounded to water pipes. You want to find if that happens. And electrical current travels through the ground wire, accelerates corrosion in pipes. So a qualified electrician will be needed to correct this problem. If lead concentration in your running water sample was less than 15 microgram per liter, one alternative, it's not the best, but it will work for the time being, is to flush your plumbing system. Because when you have elevated lead, like your first draw is higher than 15 microgram per liter, we still suggest you the first thing is remove the source. Because when you can eliminate the lead source, you don't need to worry about elevated lead in your water. But for the time being, if you couldn't locate that and your running water sample, it's lower than 15 microgram per liter, flushing your system is proven to be not, let me rephrase, flushing your plumbing system can be an alternative. Because from your running water sample already show it's less than 15 microgram per liter. And keep in mind, it may not be effective in apartment buildings with complex plumbing systems or in homes on public water sources where lead service lines are the source of lead. So here it's all like, the source is from your inside the house, it's household plumbing. Then you can try flushing the plumbing system. And also, you flushing the system is needed if the water has been in contact with plumbing for at least an hour. So which means if you haven't used the water for an hour and you want to turn on that faucet to drink, you need to flush the system at least 1 minute. I've read some studies suggest you flush the system for 2 minutes. The highest I read from a European study suggests 5 minutes, because it really depends on the water chemistry, if it's corrosive, and also the plumbing, if it's what materials are used in the plumbing system. If flushing proves effective, so the only way you know if it's effective or not is also do a running test, because lead is colorless, odorless. You don't know the concentration until you test it. So you may want to do another running test just to see, like you run it for 10 minutes early in the morning, the first thing in the morning, you let it run for, let's just say 5 minutes. You collect the sample and see if it's still lower than 15 microgram per liter. If it proves effective, so you can conserve water by flushing the plumbing system once in the morning and store water in bottles for use during the rest of the day. And also, only flush water from the cold water tap should be used for drinking and cooking, since hot water can dissolve lead more quickly than cold water. Like I mentioned earlier, it's the corrosivity of your water. And another thing, keep in mind, boiling water cannot remove lead. When you boil water, it only concentrates the lead concentration. So that's not an effective way, or that's not even a treatment method for lead. Boiling water is only effective for bacterial contamination. So there are also several types of treatment systems you can consider to resolve this problem, including reverse osmosis, distillation, and carbon filter systems. So the first one is a reverse osmosis unit. They are typically attached to the kitchen tap and treat only the water from that tap. They remove about 85% of lead from water, which is it's very effective. However, reverse osmosis can be very expensive. The costs vary. Some systems, it depends on the design and the convenience of the system. So ranging from $500 to more than $5,000. I've even seen some, it's whole house reverse osmosis, which can be very expensive. Also, reverse osmosis units, for those kitchen type of reverse osmosis, can only produce a few gallons of treated water per day, because the rule of thumb is to produce 1 gallon of water, you discharge about 3 gallons of water, because reverse osmosis use a semi-membrane, and that membrane is you need a pressure to push the water through, so not all the water can go through. That's why the production rate is quite low, probably just a few gallons of treated water per day. And another unit treatment system you can consider is a distillation units. They are also normally placed on the kitchen counter and very effective in removing lead from drinking water. About 99% of lead in water can be removed from distillation. However, they are relatively expensive to operate and produce only a gallon or so of water every day, and depending on their size. Other treatment devices, I put it here, it's active carbon. They can remove lead, but the efficiency so far it's questionable. So carbon filter, here it's a granule active carbon filter, for instance. You commonly see those filters, it's like in a pitcher or it's attached to your refrigerator. Some may be mounted on your faucet or under the sink. So for this type of filters, it removes lead. It's only efficient at removing lead when the pH is near 7. So when you have corrosive water, like lower than 7, like 6, it may not be effective. And they are fairly small, like, in the kitchen setting. So they are not very expensive. Sometimes you may experience some salesperson techniques. So try to sell you their system. They might be marketed lead removal, but to know if they do or not, just like the performance, they might be unknown or might be questionable. So if you are considering buying a home water treatment system, I will suggest checking the National Sanitation Foundation, NSF, National Sanitation Foundation's webpage. They are third party and they test the performance of these end-of-use water systems. And some systems you can see on the packaging, they already put in NSF for sign on the box. And this is this method on this slide I show you, it's the most effective, but it's also the most expensive lead removal method, is to replace the leaded components in the plumbing system with newer non-leaded components. Remember, I showed you the 2011, the act defined lead-free, like lead-free pipes. It's now 0% lead. It's less than 0.25% lead. So with corrosive water, it might still be leaching into your drinking water. And here it's non-leaded components. If you decide to switch everything to non-leaded components, so which here involves replacing copper pipes, lead solder with plastic PVC or PEX pipes. Only plastic PVC or PEX pipes approved for home plumbing use should be used for this replacement. So on the side of pipes, you should be able to see the signs indicator. It's the standard when it's NSF, against National Sanitation Foundation, NSF 61 or NSF PW. So look for those signs. And this is a very expensive when you decide to replace the whole plumbing system, but it's proven effective. And keep in mind, replacing home plumbing components will be effective only if the source of lead is within the home plumbing system. If the lead originates from lead service lines within a public water system, this method may be of limited benefits. So again, you need to know where lead is from. Is it from the plumbing inside the house, or the lead is from beyond the house? And to know that, to test, you do the first draw and you do the running test. It will help you to identify which might be the source of your lead. And with that is the take-home message. Lead is more likely to enter the home from household plumbing. Lead is a potential concern for both public and private water supply. Testing lead in your drinking water is the only way to know if you have lead in your water or not. And here's the link again. This is this webinar is a part of the private well and the septic system webinar series. We have a variety of topics. In next several months, we'll cover septic systems, and I briefly mentioned the water treatment systems related to lead removal. And if you want to learn more about home water treatment systems, this webinar will be held on September 21st. So I will introduce you some common home water treatment systems. And some additional resources. I didn't have that much chance to explain corrosive water. I briefly mentioned, so when the pH is lower than 7, it's considered corrosive, and also low in dissolved solid, it is a corrosive water. And the corrosive water control, if you have lead, let's rephrase this way, if you have a lead source in your plumbing system, corrosive water will accelerate the issue. So again, if you don't have lead source, it doesn't matter if your water is corrosive or not. But when you have lead source, when the water is corrosive, then you have a higher risk of elevated lead in your drinking water. This fact sheet is developed by Penn State Extension. That's the only one I find very helpful. So I put it here if you want to learn more about the corrosive water. Generally for Florida, especially like Central Florida, we don't have most water. It's hard water. It's not corrosive water. But when you have a water treatment, when you have a water softener, so you replace hard water with softened water, your water might be corrosive. And some parts of groundwater in Florida, especially like the Panhandle area, I know some area the water is very corrosive. So if you have these symptoms or you want to learn more, this link is very effective. This link gave you some good a good overview of corrosive water. Another news article, I call it a news article. It's a press release from Mississippi State. It's a there's a specialist there took the interview and just explain how flush water system can reduce lead levels. So I briefly also mentioned how to flush your system. So this is just another additional reading. If you're interested, flushing your system can help reduce the lead levels. More additional resources here. So for licensed contractors, you can access Florida Department of Environmental Protection's webpage. So it gave you a list of certified well contractors. The second link is the NELAB. It's certified lab under Florida Department of Health. So I checked that link. I realized some labs are still listed under NELAB. I called some labs and I was informed that they were no longer in operation. So I would say this list is not an up-to-date list. So you probably need to make a few phone calls just to find out they are still in operation and probably compare the price. And with that, you can see my contact info here, my email and our webpage. And with that, I will take your questions. So let me go to the Q&A function. I saw some attendees have your hand raised. So if we don't have the chat function, because if you put in the chat box, it will tell you it's disabled. So if you have any questions, please put in the Q&A session, because this webinar is recorded. The Q&A function will not be recorded. So your name or the questions will not be shown in recording. That's why we prefer use this method, because when you watch the recording, you can only see my face and the PowerPoint slides. All right, let me go to the Q&A session. The comparison of water test slides is fantastic. Oh, thank you. Can I have a copy of that slide for reference? Yes, of course. After this webinar, I will share my PowerPoint slides with all the attendees and give you the link to the recording if you want to watch that again. In testing water, when you have a water softener system, where should you perform the first draw? That's such a good question. So let me think how to answer it correctly or properly. Because if you send to so the question is, why do you test that water? So for us, it's like if you test water to want to know if your water is safe to drink or not, then the next question is, from that faucet, do you collect from that faucet, the water has already been through the water softeners. Because I contact, the reason I said that is I contact some certified labs, and they will tell you to disconnect your water softeners, or disconnect any water treatment systems. You only want to collect water without the water systems from a cold water. But to me, it's what's the ultimate goal for you to test that water? If you test that water, is to know, I drink that water from that faucet. I want to know if that faucet has any lead or not. So if that's your goal, I will suggest you to keep all the water system on, because that's where you get your drinking water, and you want to know if it has lead or not. So I hope I answer your question. So testing your water, yes, I will choose a faucet where you collect your drinking water, and I will not disconnect any water treatment systems, because that gave me a baseline of the water I'm drinking, what's the lead concentration. And another question here, I think I already covered that. It's asked about the recording. So yes, this webinar is recorded. I'm sorry, I didn't mention that at the very beginning. It is recorded, and all your information will not be disclosed. Like I mentioned earlier, when you watch the recording, you can only see my face at the square and the PowerPoint slides. That's also why we use QN function to protect your personal information. And you will also receive a PDF version of today's PowerPoint slides. And I got a comment from Miss Susan, said, I answered your question. That's great, and thank you. All right, I think I answered all the questions here. So if you still have questions, or if you are still typing, I don't want to miss your question, you can raise up your hand. So let me know you're still typing your question. Otherwise, we will close today's webinar. Let me just check for one more time. I don't want to miss any attendees here. So I don't see any hands up, and I think I already answered all the questions. I don't see more questions here. So with that, I appreciate your time. And if you have any questions, you see my email here. And if you want to register the upcoming webinars, after you receive the PowerPoint slides, you can just click the link there. So with that, I appreciate your time and enjoy the rest of your day. Bye.